Thousands of carefully selected materials arrive every day, each meeting the demanding standards required for spaceflight. Before production begins, every material is inspected to microscopic precision, ensuring absolute reliability. Powerful computer-controlled machines transform raw materials into components measured with micron-level accuracy. Automated welding creates structures capable of withstanding immense pressure during launch. Each section is assembled with extraordinary accuracy, guided by both robotics and advanced digital models.
Artificial intelligence allows engineers to test thousands of scenarios long before the rocket is ever built.
Behind every successful mission is a vast network of intelligent machines working together with remarkable precision. Deep inside the factory, one of the most complex machines ever created begins to take shape: the rocket engine. Every rotating component must achieve near-perfect accuracy to handle enormous pressure and extreme rotational speeds.
The combustion chamber is built to contain temperatures hotter than molten lava while maintaining perfect structural integrity. The engine nozzle transforms expanding gases into tremendous thrust, capable of lifting thousands of tons.
Thousands of precisely engineered components must function together without a single failure. Advanced robotics ensure every major assemble is positioned with extraordinary precision.
Artificial intelligence inspects millions of microscopic details beyond the limits of human vision.
This controlled test confirms that the engine is ready to power humanity's next journey into space. With the engine successfully tested, the next challenge is assembling every major section into a complete launch vehicle capable of reaching space. The first stage forms the foundation of the rocket, demanding extraordinary structural accuracy before any additional components can be installed. Installing the engine is one of the most critical moments in the entire manufacturing process. Every connection is digitally verified to ensure complete reliability under the extreme forces of launch. Advanced robotics ensure every major assemble is positioned with extraordinary precision. Multiple stages are joined together with remarkable precision to create a vehicle capable of escaping Earth's gravity. Before leaving the factory, millions of data points confirm that every component meets mission requirements. After months of engineering and assembly, the completed rocket begins its historic journey from the factory to the launch pad. Leaving the factory marks the beginning of one of the most carefully coordinated journeys in aerospace engineering. Even the smallest vibration must be controlled to protect the rocket during transport. Weather, wind, and atmospheric conditions are analyzed continuously to ensure a safe launch window. Positioning the rocket on the launch pad requires extraordinary precision and flawless coordination. The launch tower becomes the rocket's lifeline until the final seconds before liftoff. Mission control combines human expertise with artificial intelligence to oversee every stage of launch preparation. Thousands of final inspections confirm that the rocket is ready for the most demanding moment of its mission. After years of design, manufacturing, and testing, the countdown to launch is about to begin.
The final countdown is one of the most complex engineering operations ever performed, where every second is guided by precision and artificial intelligence.
Thousands of measurements are analyzed every second to ensure every system is operating exactly as planned. Artificial intelligence predicts potential problems before they can occur, increasing both safety and mission reliability. The rocket is now fully fueled with cryogenic propellants, stored at temperatures colder than Antarctica. The rocket now stands independently for the first time, moments away from launch.
Deep inside the engines, an intricate sequence prepares the rocket for the immense power of ignition.
Within seconds, Millions of horsepower come alive beneath the rocket, creating enough thrust to leave Earth behind. After years of engineering, the journey to space has finally begun. Within seconds of liftoff, the rocket begins accelerating through Earth's lower atmosphere under carefully controlled guidance. Artificial intelligence constantly adjusts the rocket's trajectory to maintain stability through rapidly changing atmospheric conditions.
Maximum dynamic pressure, known as max Q, is one of the most demanding moments of the entire ascent.
Having completed its mission, the first stage prepares to separate from the rest of the vehicle.
Stage separation allows the upper stage to continue the journey using a lighter and more efficient configuration. Advanced guidance systems enable reusable boosters to navigate safely back toward their landing site. Only a precise balance of speed and altitude will allow the spacecraft to enter a stable orbit around Earth. With the atmosphere left behind, the mission now enters its most delicate phase as the payload prepares for deployment.
After protecting the payload throughout ascent, the fairing has completed its mission, exposing the satellite to the vacuum of space for the very first time.
Every movement is carefully controlled to ensure a safe and precise deployment into orbit. Autonomous onboard systems immediately begin stabilizing the satellite and preparing it for years of continuous operation. The first successful signal confirms that the spacecraft is alive and functioning exactly as designed.
From orbit, satellites connect billions of people by supporting communication, navigation, science, and weather forecasting.
Reusability has transformed modern spaceflight by allowing powerful rocket stages to fly again and again.
Every recovered booster undergoes detailed inspection and refurbishment before returning to service.
Every successful launch expands humanity's reach beyond Earth, opening new possibilities for science, exploration. Orbit is no longer a destination, but the beginning of a new era where humanity is building permanent infrastructure beyond Earth.
Modern satellite constellations provide communication and navigation services to billions of people around the world.
Space stations serve as laboratories where new technologies are tested for future missions deeper into the solar system.
The knowledge gained from every launch prepares humanity for the return to the moon and future journeys beyond. Robotics and artificial intelligence will play a central role in establishing sustainable human settlements on Mars.
Factories in orbit may one day manufacture the next generation of spacecraft beyond the limits of Earth's gravity. Reusable launch systems and intelligent automation are making access to space more frequent and more sustainable than ever before. Every rocket begins as an idea on Earth, but its true destination is the limitless frontier of human discovery among the stars. Orbiting the moon will become a vital staging point for deep space exploration.
Robotics and artificial intelligence will enable humans to live and work on the moon for extended periods.
Using local resources will dramatically reduce the cost of building the next generation of space infrastructure. Future missions to Mars will rely on advanced propulsion and autonomous guidance across millions of kilometers. Artificial intelligence allows spacecraft to monitor, maintain, and even repair themselves far from Earth. After months of travel, precision navigation becomes the key to reaching the surface safely. Technology will transform distant worlds into places where humanity can explore, discover, and eventually thrive.
A new transportation network is emerging across the solar system, powered by reusable spacecraft and intelligent automation. Future launch systems will make access to space as routine as international air travel today. Factories built in orbit will manufacture spacecraft too large to ever be launched from Earth.
Powerful space telescopes will allow humanity to explore the earliest chapters of the universe.
Artificial intelligence will become humanity's most valuable partner in exploring worlds too distant for immediate human presence. The technologies developed today may become the foundation of tomorrow's civilization beyond Earth.
From orbit, our planet reminds us why exploration matters, to better understand, protect, and inspire the world we call home. From a single spark of engineering on Earth to the limitless expanse of the cosmos, the story of every rocket is ultimately the